Hello everyone, welcome to the course Fundamentals of Manufacturing Processes. In week 7, we'll talk about metal working processes, basically sheet metal working processes. This course is offered by Professor D.K. Dwivedi from Department of Mechanical and Industrial Engineering, IIT Roorkee, and I'm your TA Alka Changet from IIT Kanpur. So firstly, we'll be going through some sample assignment questions which will be helping you in solving your weekly assignments. After this, we'll go through some lecture notes. So first, if you know the answer of the question and if you face any difficulty in understanding the answer, you can unmute yourself and answer. And also, if you know the answer, you can type it in the chat box. So first question is, shear cutting operations like blanking needs higher clearance in case of. Your options are soft materials, hard materials, irrespective of metal, or all of these. So which one should be the correct answer? So sir taught it in 32nd or 33rd chapter, so you should know the answer. Okay, so answer will be soft materials. So in the case of softer materials, you have to consider higher of the clearance. So clearance increases with softness of material and thickness of material. So in case of hard metals, you take 6 to 10% of the thickness, and in case of soft metals, you take 10 to 18%. And increase in thickness also increases deformation zone, and harder the metal, lower is the burnishing and deformation size. Okay, so lesser will be the deformation if your material is hard. And the burr height, the height of burr that is formed here, as you can see near the pointer here. So this burr height also indicates the dullness of the cutting edge, and it becomes unavoidable. And the dullness increases penetration requirement of the cutting. And also, if there is insufficient clearance, in that case it can cause metal to compress or bulge out away from the punch, and increased friction and greater force is needed to create the hole. In case of clearance and tool chipping, so reducing the clearance can improve tool chipping risk at some point. Now here you can see after cutting of the sheet, some part of this will be having plastic deformation, and this is burnish. So up to this part your tool will penetrate, and after this it is fracture part which fractures on its own. Then after that there's some part that is coming out of the sheet plane, that will be your burr. And second question is, depth of penetration in shearing operation is calculated as. Your options are deformation depth, burnishing depth, the sum of deformation and burnishing depth, and difference between deformation and burnishing depth. So in previous you can see this part was the penetration part, and after that fracture part starts. So you have to provide this deformation until your material starts to fracture. So this burnish part and this plastic deformation part, these both combined are called depth of penetration. Okay, so depth of penetration in shearing operation is calculated as, this third will be the correct answer, the sum of penetration and burnishing depth. Okay, so here again you can see. So in case of shearing, the depth of penetration is the depth of stroke when the cutting force is applied to the metal before it breaks or fractures, and it's usually expressed as a percentage of the thickness of the work metal. The depth of penetration is roughly the sum of the burnish depth and the rollover depth of the on the blank. In case of shearing, it is also known as die cutting. Shearing is a cold mechanical cutting process which uses two sharp blades to cut sheet metal, and the lower blade is stationary while the upper blade slices through the metal. Second is burnish zone. So burnish zone is the area where the cutting tool penetrates the sheet metal before it starts to fracture. So the sheet metal compresses into the cutting tool, giving it a smooth, flat and shiny appearance. So appearance of the burnish zone and the fractured part is different. Next is tool wear. So as a tool wears, the burr height and burnish depth increases, and a duller tool can allow material to flow instead of promoting shearing, deformation and fracture. Now next is, yeah, do you have any query?
Uh, in the last slide, if, do we need to completely go the punch need to pass through the sheet, or it only need to penetrate some distance, then it will be the shear will be transmitted to the whole thickness of the sheet.
Okay,
Here
in
the
that,
penetration.
okay, so penetration will be only up to this burnishing part. After that fracture starts. So for fracture you don't require any force for the machining tool. So this part will be fractured and this part is the ones where your tool is penetrating.
So the tool don't need to go through the sheet for cutting it.
No, it don't need to go through entirely because this part will fracture on its own. You won't be requiring force in the case of fracture part.
Okay. For the soft material, it will be deformed inward like the previous slide.
In case of, yeah, can you repeat?
I mean, for the soft material, the cutting won't be. It will be somewhat in. It's not actually straight line cut, isn't it?
In case of softer material it won't be straight line. No, it will, uh, it in this case we are talking about like clearance, how much clearance is required. So for soft materials and hard materials it is different.
Okay.
Okay, now in third question you have to calculate the work required punching a circle of diameter 25 mm in a sheet of 3 mm thickness, and the material's ultimate tensile strength is 450 MPa and the required depth of penetration is 20%. So your tool will be penetrating only up to 20%, and after this your sheet will be either fracturing through that or either you don't require entire penetration. So then you have options in Newton meter. So 63.61, 36, 42.45, 10.62. So which one should be the correct answer? So in case of blanking and punching, you have very simple formulas for solving for this force and work. So you have to just remember those formulas. So in case of work required, it will be force times the penetration. So penetration is always given in terms of percentage of the thickness. So this is just the penetration depth, this part penetration multiplied by thickness. So penetration will be 20% times the thickness which is 3 mm thickness. Okay, and force you can, and for force the formula will be the shear stress times the perimeter that is coming into contact with the punch. Okay, so perimeter will be the perimeter of the cylinder that is coming in contact. Okay, so it will be pi dt. So pi will be 3.14. Your diameter is already given 25 mm, thickness is given, and your shear strength is given here. UTS is used 450 MPa, and after that you will be getting the answer as the, it will be 63617, but you have this mm 3 times. Okay, so Newton per mm, in case of that, you can like cancel the units and you'll be finding the correct answer to be 63.617 in diameter, in thickness, and thickness twice. So you are using thrice.
Ma'am, for finding that force part, we need to use that thickness value of the plate,
Yeah,
pi dt.
yeah, phi dt, entire
That's
thickness.
area into stress.
Yeah, can you
Uh,
repeat?
I mean, the force is find out by multiplying that area into stress. That pi dt is the area, isn't it?
Yeah,
Area.
yeah, pi dt is the area. That's with the light green. Yeah, it is shown here with the different blue color, right? This area which is coming into contact with the punch, that perimeter you have to use, that perimeter area. So in you can, pi dt will be like a perimeter of the cylinder. Next question is similar to previous one. Here you have to calculate the diameter of punch and die. So okay, here you don't have to calculate force or anything. Here a 20 diameter blank will be produced from a 5 sheet in the blanking operation. So you are given diameter and thickness, and the preferred clearance is 5%. The diameter of the punch and die are respectively. So size of the die will be similar to what is given for the diameter of blank. Okay, so for the punch only you have to find out what will be the size. Okay, so answer will be this one, and the formula that you will be using is the in case of blanking operation, the diameter of the die is unaltered and the punch diameter is reduced. So punch will be smaller, right? So it will be going through the sheet and it will be falling in between the die. So it will be smaller compared to the die. So it will be reduced by the 2 times clearance, because both of the sides you will be having clearance, and the times the thickness, because the thickness of the sheet will be in between that. So you have to multiply thickness to the clearance to the 2, and then minus this to the blank size diameter. Okay, so it will be 20 minus 2 times 0.05 times the 5, and again it is in percentage, so 5 divided by 100, so it will be 0.05. So it will be 20 minus 0.5. Okay, so it will be 19.5 Next question is the operation used for making of the axis symmetric conical shape product is. Your options are blanking operation, spinning operation, ironing operation, and coining operation. So in case of axis symmetric conical shapes, you use spinning operation. In case of blanking operation, you cut out some shapes from the sheet. In case of ironing, you change the length and thickness of the shape, cylindrical type of shapes or cups. In case of coining operation, you make uh, certain designs or some engraves on the coins or some cylindrical shapes. So second will be the correct answer. So this is what spinning operation looks like. Here you will be having a mandrel, so on that you will be putting your sheet and you will be giving it the shape of a axis symmetrical conical shape. So in case of metal, yeah, go ahead.
No, ma'am. Can you once again explain the ironing operation?
In case of ironings, okay, I can go to the before thrice. Yeah, ironing. So initially you have some size of this, so you'll be reducing the size of this thickness of the outer dia, you'll be reducing it, and you'll be changing the length of this as well. Okay, so it is thinning and lengthening of a wall of material.
Okay.
Okay. Okay, so this is the spinning operation. So in case of metal spinning, it refers to a group of forming processes which allow production of hollow, axially symmetric sheet metal components. And the basic technique of spinning, which is common to this group of processes, consists of clamping the sheet metal blank against the mandrel on the on a spinning lathe, and then gradually forming the blank onto the mandrel surface by a roller, either in a single step or series of steps. Next question is, die used to perform two or more operations in a single stroke at two or more different workstations is. Your options are progressive die, compound die, combination die, or return type die. Okay, so answer will be compound die. Okay, so in case of compound die, you answer should be, I think its answer should be combination die. Okay, so in case of a die is a machine tool commonly employed in manufacturing to shape metal by cutting it into desired forms or creating external threads on items such as pipes and round roots. And in case of combination die, it's combine multiple cutting and forming operations in one stroke at one stage, and they are versatile and used for various tasks such as blanking combined with deep drawing or punching combined with bending. So here you are asked used for perform two or more type of more operations in a single stroke at a two or more different workstations. So it should be combination die. Next question is, material removal process come under the non-traditional machining process. Your options are electrochemical derived processes, thermal derived processes such as fusion or evaporation, chemically derived processes, or all of these. So all of these processes, they are non-traditional machining processes. In case of traditional, you will be having only mechanically based processes. Okay, so many materials removal processes are considered non-traditional machining processes which use unconventional methods to remove material, and such as EDM, which is electrical discharge machine. It uses electrical sparks to remove material from the workpiece. And then you have electrochemical machining, which uses electrolyte and electrical current to remove material through ion transfer. This process is ideal for hard materials like stainless steel and tungsten. Chemical machining, it uses strong chemical reagent to dissolve the workpiece material. Plasma cutting, it uses high velocity gas stream to expel molten material from the cut, and this process is often used for cutting steel, stainless steel, aluminum, brass, and copper. Now, non-traditional machining processes use a variety of energies including mechanical, thermal, electrical, and chemical to remove material, and they don't use sharp cutting tools which are used in traditional manufacturing processes.
Uh, if we can order it in a based on the surface finish, it will be what order we can arrange these for the plasma. I mean, if we are ordering these for process based on the surface finish value, that I mean the finish of the cut, then in what order we can arrange it? I mean, the plasma cutting will be having more rough finishing, isn't it? Like if we are ordering it in increasing or decreasing order.
Okay, so EDM will be having like less. uh, less order of the finishing compared to these processes. In case of electrochemical and chemical as well, you can find very good precision compared to EDM, and plasma would be higher compared to these.
Uh, Plasma is having more surface finish or
Plasma will be having more surface finish. In case of electrochemical also, you can find very good surface finish up to like very in microns.
okay.
Next question is estimate the clearance in percentage required for the material having a thickness of 2 mm and a shear strength of 450 MPa. So you have to find out clearance. So answer will be in terms of percentage. So clearance is given as the formula 0.0034 times thickness and times the shear strength, under root shear strength. So shear strength you are given 450 MPa. So after using this formula, you're given thickness as well. So this will be 0.1442, and in case of percentage, you'll be getting 14.42 percentage. Next question is the drill moment for drilling operation is rotation and linear movement along the axis of rotation, rotation and circular movement along the axis of rotation, or only rotation movement, or only linear movement with no rotation. So in case of drilling, so drilling operation, I think even who are not from mechanical background, they must have seen drilling operation at some point in their life. So in that case, you will be applying rotation, will be providing you with the chip formation and uh, drilling operation, while linear movement will be for the advancement of the tool inside the stock. So this will be linear movement along the axis and rotation. First one will be the correct answer. So this is the drilling operation that is shown. So in vertical direction, you will be providing this the progression of the tool. So rotation motion, it provides cutting of material, and linear up and down movement provides progression into material while drilling based operations. The working principle of any drilling machine remains almost similar. When power is supplied to the motor, the spindle rotates, causing the attached step pulley to also rotate. So this drilling tool, it also rotates and provides this formation of holes. Next question is the ratio of the force required to punch a circle of diameter 25 mm to that of a square of 30 mm in 4 mm thick aluminum sheet. So you have to find out the ratio. So neglect other factors if any. So you have aluminum sheet, so it will be having same shear strength, so you don't require the shear strength part, okay, because it will be uh, on both sides, right? So 0.3, 0.45, 0.65 and 0.7. Which one would be correct answer? So okay, you have to basically, so for force your formula is shear stress of aluminum times the perimeter area. So you have to find the perimeter area for the both circle part and square part. In case of circle part, it will be pi dt. So pi d will be your 25 mm, t will be thickness 4 mm. And in case of perimeter of square, square will be having 4 faces, right? So if you make a square based here, then it will be having 4 faces, right? So it will be having 4 times the, then you have length of the square will be 30 mm and thickness will be 4 mm. Okay, so it will be 4 faces of 30 times 4. So the area of the circle base cylinder will be 314 mm square, and for square it will be 480 mm. Now force required for punch is given as shear stress of aluminum times the area. So P1 divided by P2. So here your tau will be the shear stress, it will be cancelled, and A1 upon A2 will be there. So 314 divided by 480. So it will answer, correct answer will be 0.65. Now we'll be going through some lecture notes. So firstly, sheet metal operations. First is shearing. So in case of sheet metal operations, metal sheet can be defined as the plates of thickness lesser than 5 mm. So you'll be working with these. If the thickness is higher, then it will fall into bulk operations. So sheet metal operations, they use different types of stresses for processing. In case of shear stress, it is primarily used in sheet metal processing. So the operations can be classified in terms of stresses that are used. In case of shearing, you have shearing operation, which is basically cutting operation with help of scissors or some blades. Blanking and these will be studying in explanation in explained way after. So other operations that are shearing based are blanking, piercing, trimming, shaving, notching and nibbling. In case of tension, you have stretch forming. In case of compression, ironing, coining, sizing and hobbing. In case of tension and compression based, you have drawing, spinning, bending, embossing and forming. Now first we have shearing, which is sheet metal cutting. So sheet metal cutting involves application of shear force on sheet by die and punch. So here you have one of the upper blade, which can be called punch, and lower plate, which can be called die, and in between that you have clearance. So it won't be at the there will be some distance between these two, upper blade and lower plate, which is clearance. Okay, so this sheet will be cut into different parts. Now die, it forms outer cutting and punch inner cutting gauge for the round parts. The space between die and punch cutting edge is called clearance. Now the mechanism, it can be seen here. So you have sheet metal, you have punch, which is moving in this direction, and then it's cutting it in half. So there are various these depths that are given here. So penetration depth you have rollover depth, you have burnish depth, then you have fracture depth, and then it is burr height. Some of the terminologies, you have die, punch, clearance and penetration. So here you have sheet workpiece or sheet metal. This is the punch, which will be moving. Die will be stationary, and in between that, between die and this outer part of the punch and inner part of die, in between that you have clearance. So clearance will be counted on the both sides. Okay, and these it should be combined with the sheet thickness. Okay, so after here sheet metal, so cutting partially completed, with this punch will be traveling downwards. Next you have shear stress and strain of shearing. So in case of shear, so you'll be having similar to the uniaxial tensile plot. So here you have elastic part, then you have elastic limit. After that you will be having yielding, meaning permanent deformation will start. Then you have this part, and after that ultimate tensile strength. After that your material will start to neck, and then there will be fracture. Now penetration of the cutting edge. So this punch is traveling, then there is with increasing size, okay, as it's keep on increasing. Here it is given up to ultimate tensile strength it will reach, and after that it will fracture. So up to that part it will keep on, punch will keep on traveling. So up to 0.010 inches penetration, and after that this penetration will keep on increasing and it will show necking and then finally fracture. Okay, after 0.60 it will show fracture initiation.
Ma'am, so we don't need to apply till the ultimate point.
Yeah, you need to apply after ultimate, because you want to fracture your this entire thing, right? So after it depends on what you are forming. If you are cutting this, then you will be requiring to apply after ultimate tensile strength if you want to fracture, and you are only making a cup and cone type of shape, or that in that case you will be applying below ultimate tensile strength and in between this yield point. So stress should be in between this part if you don't want to fracture.
But the penetration, we only need to move till only the penetration region, that 0.01 inches. Then the fracture will continue till the thickness of the tip, throughout the thickness of the sheet.
Yeah. Okay, so shearing for circular hole or blank. So here remaining sheet metal with hole, so this part will be blank, and the part that is cut out, so here it will be having different zones. So upper zone where you have extra metal up to this plane, it will be burr, and in between that you have fracture zone, and below that you have burnish zone, and in starting you will be having plastic deformation. So plastic deformation will be starting initially. Then you have penetration, which is given as percentage of sheet thickness. So whatever the sheet thickness, it will be given in percentage, such as 20% penetration or 50% penetration, that is given in terms of that. So for, as I told earlier, it will be sum of the plastic deformation and burnish. Okay, so it combined that will be penetration depth. So for various materials it will be different. So how much penetration you require, after that it will be having fracture. So in case of lead, tin, aluminum, it will be smaller. In case of as you keep on increasing, for example in steel, as you keep on increasing the carbon percentage, it will go down as the hardness will keep on increasing. Now clearance and its role in shearing. So clearance is given as the space in between punch and die. Okay, so it is space between punch and die, and it affects mechanism of shearing, cleanliness of the cut edges, force for the shearing. Okay, so if your clearance is proper, then these fracture edges, they will meet at the particular angle, right? So it will meet properly if it is clearance is proper, and if it's not proper, then they won't meet and there will be required a secondary shear. Now if the clearance is tight, or if it's very close, the punch and die are very close, then in that case there will be secondary shear required, because these fracture edges, they won't meet and the punch fracture is burnished. And if too loose of clearance, and then here it is shown too little clearance, then fractures they will miss. Okay, and If it is too loose, then there will be excessive disc shaped deformation. So a lot of part will be forming in disc shape. Clearance and cutting edge condition. So as I told earlier during one of the questions as well, clearance increases with softness of metal. So as the material is more softer, you will be taking more clearance. And for hard metals it is lesser, up to 6 to 10%, and for soft metal it is 10 to 18%. And clearance also depends on thickness, and as increase in thickness there will be increases in deformation zone. So harder the metal, lower is the burnishing and deformation size. Okay, so in case of harder material, this part penetration depth will be smaller. Burr height indicates the dullness of cutting edge and it becomes unavoidable. Dullness increases penetration requirement of cutting. Next is dimensions of die and punch and their effects. So the die's diameter determines outer diameter of cut parts across the burnishing area, and if the blank is final product, then die is made larger and punch smaller to give proper clearance, and the punch diameter determines the hole diameter, and the die diameter is made oversized enough for proper clearance. So as shown here as well, in between die and punch you are given some this extra part which is clearance, and your workpiece is of this size and your scrap will be that is cut in between this and blanking. Spring back and cold welding. So cold welding occurs when soft metals are processed, and it occurs between punch and sheet and between slug and die, and it occurs in fracture surface. So here you are shown punch and this is the blank part. So as you are traveling this punch from this side to this side, so because of spring back, because of elastic recovery, this will there will be very less space in between this and it will get stuck to this. So sheet metal sticks to punch at burnish area due to spring back and cold welding. The spring back is due to elastic deformation, and there are some stroke requirements. Force for pushing, so there are such as sheet grips for punch and blank grips for die, these are used, and diameter of hole and blank, these are also considered. So in case of die, this your scrap or this your whatever punch you have made, it might get stuck because of the elastic recovery. So here sheet metal slug sticks to die at burnish area due to spring back and cold welding. So for getting rid of that, there are some methods that are used such as stripping. So here fixed stripper are used. So this your stock, it is not directly put on the flat surface, rather than you use fixed stripper. So when this punch is traveling and coming back, it won't be sticking to the punch. Okay, so it is separation of sheet and slug from the punch. And here pushing slug out of die, so counter boring of die, an extra stroke of ram, and use of stripper like spring and air. These are some of the options. Now otherwise the slug and sheet will move up with the punch, and the stripping is affected by cut location, middle edge, length and thickness of sheet. Now for the cutting force, so for the optimum clearance you require this snapback of punch due to sudden release of the force as fracturing occurs, and then if there is no secondary shear, then it will be vertical edge. And in case of there is some secondary shear, so if your clearance is not proper and if it is low clearance, so your die and punch is very close, then there will be secondary type of shear, so there is extra stress that will be required. And if there is these are very too close, then this can be at particular angle as well, so there will be secondary shear present, but there it is not measurable. Now force required for the shearing, so it is shear area and shear strength determine the force required for the shearing. Okay, so it based on for various metals it is given here. So for example, it is keep on increasing with the higher strain. So lead is very soft material, so you require very less force. And as tin, aluminum, zinc, copper, brass, bronze, steel, stainless steel, silicon steel, and nickel, this keep on increasing except nickel, because nickel is all again softer compared to this. Then you have cutting force and work in cutting by shearing. So force is given as shear stress times shear area, and the area is given as the perimeter of cut times the thickness. So as given here in this case, you have perimeter here and you'll be multiplying it with the thickness, then you'll be getting the entire area that is coming in contact. Okay, and in case of force, you have to be having shear stress, then you have to multiply with the shear area. So here your this part is having this force at this side, and then die and punch they have force in different sides, so it will be a shear type of true shear type of stress. Now work on shearing, so work will be force times the distance. For here force multiplied by penetration, which will be percentage of thickness, so you have to multiply percentage with thickness. So here one of the example is given. So for cutting a square hole of 100 mm side in metal sheet of 2 mm thickness of 500 MPa shear strength, so penetration required is 20%. So force is given as 100 times 4 times the 2 times 500. So force will be your as given shear strength is given, and your entire area will be 100 times 4 times the 2. So this will be entire area because there are 4 faces. Now force is given in newtons, then work will be force times the distance. So distance will be penetration times the thickness. Next chapter is sheet metal operations. So in this, the sheet is deformed between two shearing blades, developing tensile and compressive stresses. And so here in some part there will be compressive type of forces, and in some part there will be tensile type of forces. So it then cracks crack nucleates and grow when material near cutting edge is elongated beyond fracture limit. Okay, so here this entire sheet, it has cut in half part. So here this part is sheared slug, this is upper shear, lower shear part, and this is the initial stock, and this is the penetration depth, and remaining part will be fracture. Okay, so first process is shearing and second is blanking. So in this case, the process of obtaining a small piece of strip by cutting. So here shearing from the stock with the help of a punch, and the removed strip is called blank, used for further processing to get usable product. So here you have punch holder and you have die holder, which is die shoe, and then you have die blocks, then you have stripper as well, so that this can be this blank that you are forming, it can be separated from the punch. Stroke will be your initial sheet that you are using. Okay, now punching will be similar to the blanking, except the objective is to make holes in the sheet, and removed strip is considered as scrap. Okay, so punching and blanking are same operations, but here in this case the sheet that is remaining, that will be your product, while in case of punching, the in case of blanking, you have the punch that you are forming, the circular part that you are forming, that will be the product. In case of punching, you are making hole, so this sheet remaining will be the product. Sheet metal cutting, so in this case various parameters are given here. So this is the punch and this is the die, and in between you have certain clearance, so the distance between this is known as clearance, and this is the diameter of punch, then you have diameter of die. Okay, so here at die will be at particular angle, so to straighten portion here, so for resharpening, and here this angle is kept between 0.25 degree to 1.5 degree. And in case of blanking, so blanking punch dia is given as dB minus 2C. Here dB is blanking die diameter, and in case of punching you have hole punch diameter. In case of punching, you will be considering punch to be punch diameter in calculation of this, and here hole die diameter will be dH plus 2C, so you will be adding the clearance. Now you have without proper gripping of sheet, so in this case if it is not correctly gripped your sheet, then there will be a lot of defects there, so it will be having a rough edge. So burr, fracture, die roll, these are all at a particular angles, these are not having very sharp edges. So while if you provide a holding force, so with proper gripping of sheet, so in this case you will be having clean and smooth edges. So burr is given here, sheared edge is here, and die roll is here, so it will be having much better surface finish in case of when you provide some holding force. Okay, and here you have used some cushion or ejector as well. You can use these various things as well. Next is trimming. So here in this case removing small amount of extra material spread out near the parting plane, such as drop forging and die casting. So trimming is shown here in this part. So here you have flash part that is formed, you will be removing this part, in this case trimming of some small parts. In case of shaving, it is removal of burrs generated during shearing process in the blanking or punching operation, so as to achieve the close tolerance work. Shaving is also given here, so in this case you will be removing these particular parts. In case of nibbling, it is removing the material in small increments to cut a specific contour on a sheet using repeating punching, and it is used when the contour is long and a separate punch is impractical and uneconomical. So this is given here, so it is a type of contour that will be formed. Notching, it is the process cutting a specified small portion of material towards the edge of the material stock. So here notching. lecture 33rd. So 33 in this metal working processes for sheet metal operations. In this case, these operations will be involving tension. So here stress forming. So you will be taking a particular sheet and you will be putting it on die to provide it particular form. So the sheet is clamped at the ends and stretched over the die so as to achieve a plastic state and permanent deformation. Okay, so here your initial sheet will be taking the shape of the die. So here you are provided these gripping jaws and the sheet metal is given certain shape by using formed die, and the you have press table and rims as well, and you will be providing this stretching type of form, type of tension type of stress. Then you have sheet metal operations involving compression. First is ironing. So it involves thinning and lengthening of the wall of the material by generating compressive stress between the die and punch, having using the clearance or spacing finer than the drawing operation. So up to 50% of thinning can be obtained in a single ironing operation. Okay, so initial thickness of the this part was this and it is reduced, so because of the reduction in thickness as well, the length will also increase. Next is
Ma'am, there will be tensile force also present in there, isn't it?
in case of
Ionic.
ironing,
Uh,
but
Here the can tape shape will be forming here.
yeah,
Can shape.
yeah.
The compressive force will be on the bottom, and will the tensile force will be acting on the sides.
Okay, so there will be combined forces, but the main force that will be there, it will be compression. By you are compressing this here in this particular part. Compression will be,
Okay.
yeah. In case of coiling, again you have compression type of force, so it is just like a cold forging operation, except that of the flow of the material occurs only at the top layers and not in the entire volume. And the punch and die, they have engraved details required on both sides of the final object, and it uses high pressure such as 1600 MPa to get the fine details on the surface. And so here your final product is in between this in black color. So here you will be having some grooves already in die and punch, and it will be providing you with some shapes on the final product. So it is for making coins, medals and impressions on the decorative items. Next you have sheet metal operations, which consist both tension and compression. So first you have drawing and deep drawing operation. So drawing is the process of making cups having height less than half diameter and similar product from metal blanks. When the cup height is more than the half of the diameter, the drawing process is known as deep drawing. So here you have the punch which is traveling, and here you have blank. So blank will be taking a shape of this shell that is given. So this is the process. So blank holding in the deep drawing. So here you have rigid blank holder. So after this punch will be traveling to this direction and it will be taking shape of this particular die. In case of here you have blank holder, draw die, and metal in this area will straighten upon further penetration. So this will keep on this part will keep on coming into this particular direction. Now these are various drawing defects. First is wrinkling in the flange. So it is small holding force. When you'll be having small holding force, then you'll be facing this type of defect, wrinkling in the walls. Okay, so it will be due to again insufficient holding force and wrinkling initially occurring on the flange. Tearing, so it will be having high stress and sharp die radius. Okay, so tearing will be along the edges, so due to high stress and sharp die radius. Earring, so earring will be at the edges, so it will be due to anisotropy of the material. Surface scratches, it will be due to the not proper surface finish of the die and punch. So die or punch will not be having a smooth surface and insufficient lubrication. Next you have spinning. So it is used for making axisymmetrical cup shaped articles, and the force will be moving is applied on the rotating blank, and it is held against a form block so as to get shape of the form block of wood. It can be of different metals as well. So this is the form block and this is the blank. It will be given shape of this form block with the help of roller. So final shape will be like spun cup or this shape. Next we have bending operation. So operation of deforming a flat sheet around a straight axis at a neutral plane. When material is subjected to plastic deformation, the neutral axis moves downward due to differential strain on both sides of neutral axis as the material oppose compression in much better way than tension. Nomenclature of bending and type of bending methods are shown in following figures. So here you have neutral plane, and above this you will be facing tension. Below this your material faces compression. So it can be wiping type of die. So here you have provided some workpiece and your upper die is moving in this way, so it will be taking shape of this one. And it can be having V die as well and U die as well. So here in case of V, it will be deformed in this shape, in V shape. In case of U die, you have a punch in this way and die in this way. Other bending operations are straight flanging, stretch flanging, shrink flanging, hemming, seaming and curling. Embossing, so it is an operation of making raised figures and letters on sheets with its corresponding relief on the other side, and the process involves drawing and bending of the material, and it generally used for increasing the rigidity by localized deformation and for decorative sheet work. So punch and die, in between that you will be provided particular designs or some figures or names that can be engraved on the on your metal sheet. In 34 lecture we'll be talking about dies and die sets. So in case of blanking and punching, you will be having assembly in this manner. So here you have punch that will be traveling and moving. In between that we have stripper, and also in below that we'll be having a block stock. Okay, so this sheet will be put here, and below that we have dies. So dies, below that we have die holder or die shoe. Then we have press base, and above punch will be having punch holder, and this punch holder will be then attached to the press ring. Okay, so after, in case of blanking operation, we'll be getting blanks, and in punching operation there'll be punching. So by definition, a die is a machine tool commonly employed in manufacturing to shape metal by cutting it into desired forms or creating external threads on items such as pipes and round rods. The dies are designed with chamfered edges on one side to facilitate the initiation of threads. The die stocks, they typically operated manually or constructed from the materials such as high carbon steels, high speed steel and alloy steels, and they come in both circular and square shapes. The dies are categorized based on their specific applications, including stamping dies for press work, casting dies for molding processes, and drawing dies for the wire production. So a lot of processes that are done using dies are, first is cut off. So here you'll be having die and punch for cutting off the sheet, or drop through, where you'll be having trimmed cups. So various types of dies can be there. Then you have return type of die, where you'll be having some spring on the dies, which will be used for the return of the blank that is formed. Then you have compound type of die. So in this case, so what is the difference between compound and combination? So in case of compound, you will be having similar type of operations combined in one stroke and one stage, while in case of combination you will be having different type of operations. So in combination we'll be having cutting and forming operation combined. In case of compound die, it is employed when multiple cutting operations are conducted in a single stroke at one stage, and this die type offers certain advantages and limitations. So advantage is that it has high production rate, since one component is produced per stroke, and it has limitation of compound die. It is higher force requirement compared to other die types, and it is complex design and manufacturing for more than 3 operations. In case of combination die combine multiple cutting and forming operations in one stroke at one stage. These are versatile and used for various tasks such as blanking combined with deep drawing, or punching combined with bending. Advantage will be high production rate due to simultaneous cutting and forming operations. In case of progressive die, we have progressive dies which are designed for multiple cutting operations in a single stroke but at different stages. The punched out sheet progresses from one stage to another until all the punching operations are completed, with blanking as the final step. The advantage of progressive dies, so it is comparable high production rate as in compound dies, and it has reduced force requirements which are achieved through shear or staggered punches. It has easier design and manufacturing due to operation being performed at different stages. Disadvantage is that its balancing forces on the punch head can be challenging, and it requires setup procedures and precise alignment. It has entire die set which is removable in case of single station is damaged. It's also heavier compared to single station dies. Now these are the assembly of various dies. So this is how it looks like. So this is the punch shoe, and the lower part will be die shoe. So above this you will be having this die which is die half, then you have punch half. So punch half is punch shoe connected to the punch, and punch will look like this. So punch made of punch steel, and die is made of die steel. And these are designs of other different dies. And next chapter is material removal processes. So up to this part we have read about sheet metal forming. Now we go to the material removal processes. So this is basically machining. Okay, so definition wise, what is machining? So machining is a subtractive process used to get desired shape, size and finish by removing surplus material in the form of chips by a cutting tool and by providing suitable relative motion between the workpiece and cutting tool. Okay, so you can remember this definition by remembering lathe machine operation. So there you will be having a particular tool which will be moving relative to the workpiece. Cutting tool, it removes excess material through direct mechanical contact. Machine tool, it will be providing necessary relative motion between workpiece and tool. Now the basics of shape generation by machining. So there are two relative motions. One is between work and tool, generally between produced surfaces. So one is cutting speed, line generated by it is called generatrix, which is primarily cutting motion. Feed speed, which is line generated by it, is called directrix, and it is secondary cutting motion. So how your entire machine is how your cutting tool is moving, and how your the entire machine relative to the workpiece is moving. So these can be at particular angles, they don't need to be parallel. So the relative motion needed for various types of surface generation. So this can be directrix perpendicular to the plane of generatrix in case of, so it can be at angle as well. So types of machining processes based on the angle between cutting edge and cutting velocity. So in case of oblique machining, cutting edge of the tool is inclined with normal to the cutting velocity. In case of orthogonal machining, your cutting edge of the tool is perpendicular to the direction of cutting velocity, and the cutting forces, they act along all three directions, x,
Ma'am,
y and z axis. Yeah.
by meaning the cutting velocity is the rotation of the tool movement. Is a movement of the tool is termed as cutting velocity. I mean, if you are reducing the diameter of a rod in the lathe, then the cutting velocity will be the movement inward to the uh, diameter of the tool, or is it that the rotation into pi d n by 60?
It will be like for cutting edge of the tool, cutting edge meaning your tool, how your tool is moving, so it is moving in rotational part, so that will be a particular type of direction, while your cutting velocity will be, velocity is moving in the perpendicular to the your material, it's moving in that direction. So how your tool is moving relative to the machine.
Okay.
So cutting forces, they act along all three directions, and in case of this orthogonal machining, you have cutting forces act along x and z directions only. So no cutting force along the y direction. The examples in oblique, you have turning, milling, drilling and shaping. In case of orthogonal, you have sewing, broaching and parting off of the tube wall. So here you are also told what are the particular angles in case of orthogonal and oblique cutting. Then according to type of cutting tool, you have three types of machining processes. First is using single point cutting tools. In this case you have turning, facing, necking, parting off, boring and shaping and planing. In case of multi-point cutting tools, you have milling, drilling, reaming, knurling, tapping, hobbing, broaching and sewing. In using abrasive as cutting tool, grinding, honing, lapping, super finishing, polishing and buffing. These all are finishing processes. So I'll be going through question answers once again. If you have any query, you can ask. So
Now,
yeah,
from the last slide, there was a parting of, by meaning parting of, there is a necking. Necking means reducing the diameter,
yeah,
by meaning the parting of, is it cutting off or shearing operation like that?
I need to check. Let me see the definition. Okay, so it is a machining operation on the lathe which cuts a section of material from a bar that's held in the chuck. So it is just a cutting operation.
So it's just removing, cutting the workpiece from that material.
It's a cutting operation, machining operation on a lathe which cuts a section of material from a bar that's held in the chuck. So in the chuck that is there, so it will be cutting some part of the bar.
Okay, ma'am. And also, can we categorize this abrasive cutting in the multi-point cutting?
Which one?
Abrasive cutting, I mean the it will be having a lot of cutting points, isn't it, for grinding, and there will be a lot of abrasive
In
particles. So
case of
can we?
abrasive, you have like it's multi-point, but it's like different compared to milling. In milling, you'll be having a particular tool that is moving in particular direction. In case of grinding, your entire surface will be coming in contact with the your abrasive part. So abrasive wheel will be there. In case of grinding, you have abrasive wheel. In case of polishing, buffing, you have different type of like finishing. For that you have various points that will be coming in contact.
Ma'am, so if there is any match the following or any odd one out, like we can remove the grinding, I mean the abrasive from this multi-point.
Can you repeat the question? I didn't get.
I mean, if there's a question for match following or like odd one, pick the odd one out, like question. If there is a grinding operation in the multi-point
Yeah, yeah,
section, okay,
it will be yeah, odd one out.
okay, ma'am.
Yeah, in case of odd one out, you need to, yeah, you should remember like which one are the sheet metal processes as well from bulk. Those you can be asked, and you single point to multi point. Need to understand which one will be single point and which one would be multi point. You can remember this particular slide.
Okay, and also there was a slide for that oblique cutting, isn't it? For the oblique cutting is actually the for the orthogonal machining, we are actually assuming that it will be in a plane, isn't it? So, can we actually say that these examples will be orthogonal machining? I mean, for the making the derivation that we are assuming that in that. single plane, it will be
This is basically based on like how your tool will be moving and relative to the your workpiece. So based on that, these are decided. Like in case of oblique machining, it will be turning, milling, drilling and shaping. They will be they won't be inclined with the normal to the cutting velocity, while in case of it will be perpendicular in case of orthogonal machining. So the examples are sewing, broaching and parting off.
okay.
Okay. Okay, so I'll be going through questions once more. If you have any query, you can ask. So first question was shear cutting operation like blanking needs higher clearance in case of, your options were soft materials, hard materials, irrespective of metal, or all of these. So your clearance depends on the both softness of material and the thickness of material. So here you are told based on the material property. So for soft material you will be requiring more of the clearance. In case of hard, or percentage can also be asked. So for hard metals it will be 6 to 10%, and for soft materials it will be 10 to 18%. And which metals will fall into soft metals, that also you can remember. So one of the slides had all soft metals. Okay, so here initial metals are soft metals. So lead, tin, aluminum, these fall into soft metals. And the steel, silicon steel and other titanium and all, those will be falling into hard metals. Okay, so your clearance will be depending on the softness of metal and thickness of the metal. And with increase in thickness there will be increase in deformation zone. And also harder the metal, lower is the burnishing and deformation size. So there will be less depth of penetration in case of harder metals. And the burr height will be also, this height will also be depending on the softness of metal as well. So and also if there is insufficient clearance, then it can cause metal to compress or bulge out away from the punch and having increased friction, and also greater force will be needed to create the hole. Clearance and tool chipping. So with reduced clearance it can improve tool chipping risk at the some point. Next question is depth of penetration and shearing operation is calculated as. Your options are deformation depth, burnishing depth, the sum of deformation and burnishing depth, and difference between deformation and burnishing depth. Answer will be sum of the deformation and burnishing depth. So this diagram, this particular diagram you can remember. So initially your material will be subjected to the plastic deformation, and then there will be burnishing zone, then there will be fracture zone, then burr height. So these all, so initial part burnish and plastic deformation combined is called penetration depth. So in case of shearing, the depth of penetration is the depth of stroke when the cutting force is applied to the metal before it breaks or fractures, and it's usually expressed as the percentage of the thickness of the work metal, and the depth of penetration is roughly the sum of the burnish depth and the rollover depth on the blend. Shearing, it is also known as die cutting. Shearing is a cold mechanical cutting process which uses two sharp blades to cut sheet metal, and the lower blade is stationary while the upper blade slices through the metal. Next is burnish zone. In this zone, it is the area where the cutting tool penetrates the sheet metal before it fractures, and the sheet metal compresses into the cutting tool, giving it a smooth, flat and shiny appearance. Next is tool wear. It is as the tool wears, the burr height and burnish depth increases, and the duller tool can allow material to flow instead of promoting shearing, deformation and fracture. Next question is, calculate the work required punching a circle of diameter 25 mm in a sheet of 3 mm thickness, and the material's ultimate tensile strength is 450 MPa and required depth of penetration is 20%. So your options are 63, 36, 42 and 10 Newton meter. Answer will be 63. So for work required, you have to remember this formula: force multiplied by penetration depth. Penetration depth will be penetration percentage multiplied by thickness, and here your force will be the shear strength times the penetration area. This area will be this particular to the where it's coming in contact with the punch, the sheet area. Okay, so it will be pi dt. So diameter is given, thickness is given, shear strength you can consider ultimate tensile strength here, and the answer will be 63.617 Newton meter. Next question is 20 mm diameter blank will be produced from a 6 mm sheet in blanking operation, and the preferred clearance is 5%. Okay, the diameter of the punch and die are respectively. Your options are 20 mm and 20 mm both, or 19.5 mm and 20.5 mm, 19.5 mm and 20 mm, and 19.5 mm and 19.5 mm. So in case of blank operation, the size of the blank will be similar to the size of die. Okay, so die size will be 20 mm, and in blanking operation diameter of die is unaltered, and punch diameter is reduced by 2 times the clearance multiplied by thickness. So you have to minus this entire thing, 20 minus 2 multiplied by 0.05 times the 5. So it will be 19.5 mm will be the punch size, and die size will be as it is 20 mm. Next question is, the operation used for the making of axis symmetric conical shape products is. Your options are blanking operation, spinning operation, ironing operation and coining operation. So answer will be spinning operation. So metal spinning, it refers to the group of forming processes which allow production of hollow, axially symmetric sheet metal components. And the basic technique of spinning, which is common to this group of processes, consists of clamping a sheet metal blank against a mandrel on a spinning lathe and gradually forming the blank onto the mandrel surface by a roller, either in a single step or series of steps. So here you will be having this sheet and mandrel, and this sheet will be rolled with the roller and it will be given shape to this mandrel. Sixth question is, die used to perform 2 or more operations in a single stroke at 2 or more different workstations is. The options are progressive die, compound die, combination die, and return type die. So answer will be compound die. So answer will be combination die here. So it's different type of operations which can be. A die is a machine tool commonly employed in manufacturing to shape metal by cutting it into desired form or creating external threads on items such as pipes or round rods. In case of combination dies, it combines multiple cutting and forming operations in one stroke at one stage, and these are versatile and used for various tasks such as blanking combined with the deep drawing or punching combined with bending. Advantages are it has high production rate due to the simultaneous cutting and forming operations. Seventh question is material removal processes come under the non-traditional machining process. Options are electrochemical derived processes, thermal derived processes such as fusion and evaporation, chemically derived processes, or all of these. So answer will be all of these. So non-traditional machining processes use a variety of energies including mechanical, thermal, electrical and chemical to remove material, and they don't use sharp cutting tools which are used in traditional manufacturing processes. So many material removal processes are considered non-traditional machining processes which are unconventional methods to remove material. So first is electrical discharge machining, EDM. It uses electrical sparks to remove material from the workpiece. And electrochemical machining, it uses an electrolyte and electrical current to remove material through ion transfer. And this process is ideal for hard materials like stainless steel and tungsten. Chemical machining uses a strong chemical reagent to dissolve the workpiece material. Plasma cutting, it uses a high velocity gas stream to expel molten material from the cut, and this process is often used for cutting steel, stainless steel, aluminum, brass and copper. Next question is estimate the clearance in percentage required for the material having a thickness of 2 mm and a shear strength of 450 MPa. Options are 18%, 14.42%, 13.83% and 12%. Answer will be 14.42%. So clearance formula is given by 0.034 multiplied by thickness multiplied by under root shear strength. So here your thickness is given as 2 mm and shear strength is given 450. So correct answer will be 0.1442 and in percentage it will be 14.42%. Ninth question is the drill movement for the drilling operation is. Your options are rotation and linear movement along the axis of rotation, and rotation and circular movement along the axis of rotation, only rotation movement, or only linear movement with no rotation. Answer will be rotation and linear movement along the axis of rotation. So this can be explained as the rotation motion provides cutting of material and linear up and down movement provides progression into material while drilling based operations. And the working principle of any drilling machine remains almost similar. When power is supplied to the motor, the spindle rotates, causing the attached step pulley to also rotate.
Ma'am, here if we explain the generatrix and directrix, the generatrix will be circular motion and directrix will be straight line.
One second. Okay, we had, yeah. So feed speed and cutting speed. So cutting speed is line generated by it is called generatrix. Primary cutting motion. Secondary cutting motion, it is feed speed. So feed will be, you will be providing feed in where workpiece will be moving corresponding to the cutting tool. So that will be perpendicular and cutting motion will be rotation. So cutting speed will be rotation, so that will be generatrix, and directrix will be perpendicular to the, so where your cutting tool is moving, directrix. One second.
Okay.
So directrix is perpendicular motion and generatrix will be this circular motion. Next question is the ratio of the force required to punch a circle of diameter 25 mm to that of a square of 30 mm in a 4 mm thick aluminum sheet. So your ratios options are 0. 0.3, 0. 0.45, 0.65 and 0.7. So here you have to basically calculate the parameters. So for perimeter of this cylinder it will be pi dt, and for square base shape it will be 4 times the face area. So face area will be thickness times the length of the square. So it is 30 mm. So 30 mm times the 4 times the 4. So this will be entire area and pi dt will be area for the circle base cylinder. So force will be your shear stress of aluminum times area. So shear stress aluminum is same, so it will get cancelled, and area ratio will be 0.65. Okay, then we went through lecture notes based on shearing operations. So here we defined what is shearing, metal cutting operations, and okay, next chapter was, it was again shearing operations. Okay, sheet metal operations second, blanking and all trimming operations, these we studied. Then sheet metal operations based on different type of stresses such as tension and tension compression. Then we went in details of dies and die sets, types of dies, and then we finally went through material removal processes, machining. So machining definition and types of machining, and types of machining based on cutting tool. Okay, that's it from my side. Do you have any
Ma'am,
question? Yeah.
can you, in the last class I have asked about that how to the timing for that night trading and
Nitriding, carburizing, right?
approximate time for that night trading, cyaniding and carburizing.
Approximate timing. So in one of the CP Sharma book from heat treatment, I found like exact time for like for particular depth, how much time you are required for nitriding. So one second, let me find that book.
Okay. Also, ma'am, is there is a JRF of given by the CSRA labs. So is it these JRFs equivalent to the MTech?
JRF is equals, I, JRF is will be equal to PhD initial years, like I think.
PhD.
Yeah. So like what is the stipend that you are provided in JRF?
They are giving approximately 37 or 31 to 37 range.
Yeah, okay. So in PhD initial years, you are given around 35 to 37,000 rupees as a stipend.
But this JRF is actually 2 years, isn't it? So there is also an SRF called Senior Research Fellow. So these combining these two, can they award the PhD, or will it be equivalent to MTech, like Junior Research Fellow? Do you know anything about that?
No, how JRF will be equal to MTech? I don't think so. Like it won't be counted as a degree, but if you have, for example, if you are applying for some job which has MTech required, then they will be counting JRF as a experience. They won't be counting as MTech for example.
Okay, so if they are asking for MTech, we can't put the JRF instead of MTech.
Yeah, I don't think you it will be as counted as that. You need to ask to some professor, I think another professor regarding that.
Okay.
Oh, fellowship. Okay, I was searching for the night riding process, right? Okay, so for night riding, it's given like if your question was related to this, can you, are you still there?
Yes, ma'am.
Yeah, so in case of night riding, it's given like the case depth of 0.5 mm is for 100 hours in case of night riding. So is
Night
your question framed in this way, like how much time is required or how much case depth is required?
for night riding, 100 hours for how much, ma'am?
So for 0.5 mm is 100 hours. The furnace container is made of heat resisting alloy steel. The time required. So time varies from 21 hours to 100 hours, and it depends on the desired case depth and size of the steel cord.
Okay.
And night riding is done at lower temperatures compared to carburizing. That one I think you already asked that, right? So it will require higher timings compared to that. So timing
So
will
the
basically depend on the case depth, how much case depth you require. So for that you must have formula as well. For case depth you are given formula, right?
uh, actually, only the list, they have only given this much case that will be given, and this much amount of temperature will be given. I haven't learned any formula.
In case of carburizing you have a formula. Let me see if it is given. So case depth is given by K times under root T. So K is constant and T will be the case depth. Freezing time varies from 6 hours to 8 hours. that T will be time. So case depth will be K times under root T. At a given temperature, the depth of penetration is dependent on diffusion and can be related to the time T by the equation case depth equals to K times under root T. And your K will be a constant. So I think they will provide K if they want you to answer for the time or case depth.
Okay, and for the carbohydrate, it will be k times root of t, and the t will be the time,
Yeah.
k will be the k step.
Huh. No, K is constant and case depth is equals to K times root T.
Um, k times root t will be the
Case depth equals to K times root T. K will be your constant, T will be time.
okay,
So as you keep on increasing the time, your case depth will keep on increasing. Okay, and it will be in root. Your T time will be in root.
okay.
So I
For
think
the
this
cyaniding also, uh,
yeah.
for the cyaniding, will there be any relation of value?
Cyaniding, they haven't given a formula, but for cyaniding they haven't given.
There is no time also.
That in that case also it will, your depth will keep on increasing with time, but what is the actual formula, it's not given. In case of cyaniding, you will be having both type of atoms, carbon and nitrogen, so it isn't given.
Okay.
And the book that's there, its book's name is, let me check, Heat Treatment by CP Sharma. I think it's available in PDF form as well. Heat Treatment Principles and Techniques.
Heat treatment principle techniques by CP Sharma. CP.
Yeah, CP Sharma.
Okay, thank you.
TV Rajan, CP Sharma, Ashok Sharma.
This TV Rajan is when I searched that the TV Rajan name is given. So is it one book?
Yeah, it's one book, three authors,
Oh,
TV Rajan,
okay,
CP Sharma, and Ashok Sharma.
okay.
Okay, for JRF also, like students who receive JRF GATE fellowship can register for a PhD at any institute. This is a scholarship that is
Yes.
and JRF is pursued after MTech degree.
But JRF is also given for the BTech students.
Eligibility. The eligibility for JRF in engineering and technology makes a master's degree in engineering and technology. And JRF is not counted as experience, meaning it's not considered as experience.
So the JRF won't be considered as job experience.
It will be like if you'll be JRF helps you in terms of when you'll be publishing some papers or you'll be doing research, that will be counted as, it won't be counted as, I think it won't be counted as a degree. Like the much you'll be getting from MTech, it will be counted as degree, then you'll be getting research part as well. And JRF, don't know, it's showing like for eligibility you require MTech master's degree before this, MSc or this like master's.
Okay.
So wherever you are applying, first check eligibility as well for JRF, where you are applying, whether it requires any
Actually,
master's
for
degree.
the JRF that I have, it's actually given BTech. BTech they have given. So I was thinking whether the JRF could be done instead of the MTech.
Okay. So JRF
Okay.
will be helping you in terms of learning about research, and it will be helping you with publishing papers, and the paper part will be helpful in like applying for interviews afterwards.
Okay.
Yeah.
Ma'am, I have no more questions, so I can leave.
Yeah, yeah, you can leave.
Thank you.